Welcome back, learners. So in the previous session we have discussed the application of the loads, either it may be dead or it may be live, anything on the frames, right? Again, in the frames, when the load application you want it to be, either you want it in the form of dead point load, you want it in the form of uniformly distributed load, you want it in the form of uniformly varying load, all kinds of loads application has been seen. So after that, the another two types of loads that you can expect is has tendon load and the joint load. Now, when it comes to the tendon loads, these tendon loads are mainly applicable when we are making the structure as a pre-stressed structures or the post-stressed structures. So when we were designing a pre-stressed concrete structures or the post-stressed concrete structures, there instead of providing the reinforcement, so we will be providing the tendon. It will be stressed initially, and after the casting of the member, so the stresses will be released. So that is what we call it as pre-stressed. Okay, so in such kind of members, that when you are doing the pre-stressed or the post-stressed members, okay, so we will be using the tendon. In such cases, what loads to be applied on those tendons? So in order to do that, we are going to use these tendon loads. Okay, and when we were doing the pre-stressed concrete members or the post-stressed concrete members, you will be having the various number of losses. Okay, we'll be having the various number of losses. Okay, so due to the various reasons, okay, because of the friction and because of the proper joint, okay, so due to those reasons you will be having the various losses. So the losses also has to be considered properly in the design. So in such cases also, so we have to predefine the losses, and those losses has to be incorporated as the loads in order to finalize the design components, that is the number of tendons required, what is its dimensions in order to do those things. So losses is also required, therefore even that has to be considered. So that time we will be using these tendon loads and losses. And finally, when it comes to the joint loads, okay, finally when it comes to the joint loads, so as the name itself indicates, the joint loads, in the sense, if you want to apply any loads for the joints of the members, whether it may be for the one member or it may be for the entire joints in the member, entire joints in the structure, that is not going to matter. But if you want to apply loads for the joints, okay, if you want to apply loads for the joints, so in such case we will go for the joint loads. We can see that the first one is force. If you click on that, again you can have an option to choose that. Let us say, for example, I am choosing this joint. Okay, so now for this joint you want to apply the load to be dead load, or you want to apply the load to be live load. Okay, that can be chosen. And again, these options you have already seen: replace the existing load, or you want to add some load to already the load applied, or you want to delete it. Okay, so like this. So then you can see that what should be the force global X, what should be the load that you want to apply. Let us give it as 2. Okay, the force in the global Y, that what you want to give, let us give it as 3. And the force in the global Z direction that you wanted to give it as 1. Similarly, the moment also you can give it as 2, okay, 4 and 5, and you can apply. Okay, you can see now at these joints all this moments and loads has been applied. You can see, so with the arrow mark will represent the force. You can see this is Y direction, so 3 has been given. Okay, this is X direction, 2 has been given. Okay, and this is Z direction, 1 has been given. Or what we will do is we'll just delete this, so that first we will apply the loads. Okay, first we will apply the loads, then we will apply the moments, so that you will be getting clear. You can see now. Okay, 1 second, I will make it to 3D. Yeah, you can see now. So this is 1, in the z, this is 2 in the y, this is 3 in the y, 2 in the x. Okay, yes. So this is how about the forces. If you want to apply the loads, then you make these as 0, moments you can make it as 2, 5, 3, you can apply. You can see now the moments will be applied like this. It will be shown like this. Okay, it will be shown like this. Yeah, it will be shown like this. Yes, so you can see that in the x it is, in the y it is 5, in the x it is 2, and in the z it is 3. So like that you can apply any kind of loads. Okay, yes. So this is about application of the loads in the joints. Okay, similarly forces. The next that you can have is ground displacement. So the ground displacement will come into picture usually when you have earthquake, but specifically if you want to have some particular displacement of the joints. For example, I'll tell you, you have an hospital buildings. Okay, in the hospital buildings, in one particular floor you have kept the MRI scanning machines. You know, the scanning machines or the X-ray machines will create the lot of vibrations, displacements. So these vibrations has to be accounted when you are doing the design of the members. Okay, so in such case what you can do, the joints which is available at that areas, for example, now I will tell you. Okay, now I will tell you, let us assume that this, okay, so these four at this level you are keeping some or at the top itself you can consider, in order to just understand the concept. You can see that here you are keeping some vibrating machine, so therefore the effect may be there here, here, here and here. So therefore in order to make the joints very safer or very successful, what you can do, you have to consider that effect here also. So from the mechanical properties of those vibrating machines, you can find out what is the ground displacements that you have. Okay, so those ground displacements can be incorporated here. But keep it in mind, students, practically that is the reason, if you see most of the hospitals, all your vibrating instruments, whether it may be X-ray, whether it may be CT scan, or whether it may be MRI scan, wherever the instruments which is having the vibrations, they will not be usually placed in the higher floor levels. It will be maximally planned in such a way that it will be made to come on the ground level itself. I know it is sometimes, it is definitely not possible that always you can have it on the ground level. No, you can have it in the top or in the other floors also, nothing wrong. But if you are keeping, these vibrations also has to be taken into consideration. When these vibrations to be taken into consideration, definitely your the internal forces in the members is going to increase. So when the internal forces in the members is going to increase, definitely the size of the members, the reinforcement of the members, everything has to increase. So that's why usually what we prefer the vibrating machines to be at the ground level. But in case due to the lack of availability of the spaces, or as per the architectural plan, if you want to keep it in the top, definitely we can keep. So therefore let us consider this joint now like this. Okay, so let us consider and let us take this as live, and you can give what displacements that you wanted to give in inches. In the x direction, let me give it as 5. Okay, so this is only the displacements. So as well as the rotations will also be there. You can give it here in the y as around 5, sorry, already given 2, and this you can give it as 3, and let us see that what it is going to apply. You can see that the displacements has been considered now at all these joints. Okay, you can see the displacements. It has been 3. Okay, this has been 2, this has been 5. So this will be incorporated when we are analyzing it. Okay, this will be incorporated when we were analyzing this. In the same manner, if you don't have displacements, if you want to have the rotations, that can also be done. Instead of giving this, okay, you can give the rotations like 5, 2, 4 like this, and you can apply. This will give you the rotations, nothing but movements, twisting movements. So like this, anything can be considered on the joints. In the same manner, even in the joints, the temperature can also be considered. Okay, the effect of joints can also be considered. Okay, definitely especially when you have the buildings to be done in the colden regions as well as the hot regions, where both the extreme temperature variations are available. So there the effect of temperature variations has to be considered. Or sometimes when you have the buildings with the thermal regulations structures, like for example, if you go for any milk factories, okay, where you can see that due to some pasteurization process, some rooms will be made in such a way that it has to be under cold condition. The inside of the building will be very cold, whereas outside will be extreme hot. There will be a lot of temperature variation. Or if you go to any iron manufacturing industries, again inside it will be very hot, where outside it may not be that much hot, it will be normal temperature. Again a very huge temperature variations will be there. So that will also create lot of stresses especially. So even that effect also it has to be considered, right? So therefore what you can do, you can choose some joints and you can have the temperature effect also. Okay, you can have the temperature effect also like this, like what should be the value, 20 degree Fahrenheit, like that you can apply. So that effect again it will be considered when the analysis is going to be done. Okay, so this is about complete assigning the loads part. So in the next video, let us start with the analysis procedure. Okay, we'll continue in the next class. Thank you, learners.